So when you arrange objects and they get used up, it's called a permutation. So the idea is, what would happen if you took a word like Kelowna and wanted to make a word scramble for someone? How many different ways could you scramble the letters? Well, you would have 7 decisions to make. What letter are you going to put first, then second, then third, then fourth, then fifth, then sixth, then seventh? Does it make sense for the first one? You could choose any of the 7 letters. And then there would be 6. And then you've used up 2 letters, and now there's 5 letters left. And so the numbers go down by 1 each time because we're using up our number. Okay, so it becomes 7, 6, 5, 4, 3, 2, 1. And in this unit, we get introduced to new notation. And the new notation in math that you've probably never seen before is an exclamation mark. This doesn't mean that you just yell out the number and be very much 1. No, we say 1 factorial. But a very excited 1 is kind of boring because it's only equal to 1. So this means 1 is equal to 1. And next door neighbor to 1 is 2, and because 1 is so calm, 2 is equal to 2. But 3 is 6. And 4, well, that's 24. Any guesses what 5 would be? It's bigger than 60. 120. How do they get that? How do they get that? And then what would 6 be? 720. Do you see the pattern? How did we go from here to here? How do we go from here to here? How do we go from here to here? This one you multiply by 4. Then you multiply by 5. Then you multiply by 6. And here you multiply by 3. Does the pattern keep working even if we go up? Yes. You multiply by 2, which didn't make much of a difference at that point. But the numbers get very big very quickly. In fact, if 720 is 6 times 120, and 120 is 5 times 24, and 24 was 4 times 6, and 6 was 3 times 2, and 2 was 2 times 1, the exclamation mark just means you start with that number and keep multiplying all the way until you get to 1. And this is called factorial notation. In fact, Kelowna, it happens enough in mathematics that we invent a symbol for it. You could have, instead of written 7 times 6 times 5 times 4 times 3 times 2 times 1, written 7 factorial. What's 720 times 7? 5,040? See if you can find the exclamation button on your calculator and type it in. It's going to be on there somewhere. Found it? Can you type in 7 factorial? See if you get 5040? I think it's the trickiest on the graphing calculator. You found it? Where did you find it? Yes, you have to hit the math button on a graphing calculator. Maybe, yeah, it's going to come up. So one way you can do it on the graphic calculator, so if I do 7, I can hit the math button. I have to go all the way over to probability, and then the fourth one has the exclamation mark. There's probably also, you know how we have the fraction button? We have the function button. It's there under 9 as well. So a couple of ways you can find it on your graphing calculator as well. And this lets you multiply all the way down to 1. Okay. At the bottom, they have the formula. N factorial, you start off with a number. Then you go 1 less. Then you go 1 less again. And you keep going until you go down to 1. We also are going to need, and this is just a definition, this makes no sense according to the other formula, we are going to need that 0 factorial has to equal 1. If 0 factorial doesn't equal 1, certain formulas that we're going to use in this unit will not make sense. But it doesn't fit the normal pattern. Okay? The normal pattern only works for n bigger than or equal to 1. And it only, for us, we're only going to deal with whole numbers. Okay, so if you go to your calculator and you try to do -3 factorial, your calculator's not going to like it. Because if you started at -3 and went 1 less, you'd get to -4, and then went 1 less, you get to -5. Would you ever get down to 1? No. Okay? We will also, in ours, only do factorials with full numbers, even though weird things happen on your calculator. Oh, that one gave us an error too. Okay. Sometimes they have certain decimals seem to work. But that's good. We're just going to do whole numbers for factorials. Okay. So we get to our first example. Oh, I'm going to give you puzzles that are going to make your head, give you a headache. Okay, puzzles in this unit. We've got the word education. We'll start off with this one. Education is 9 letters long, so if you wanted to scramble it, does it make sense that you could make 9 spaces? And say, I have 9 choices. Any of the letters could go first. But if you've used up a letter, how many choices would you have for the second letter? Then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1, which is 9 factorial. Do you know what's really cool about the word education? It uses all 5 English vowels, which is cool. So then it makes you think, are there other English words that have all 5 vowels? And then, can you think of the shortest one possible? Now, apparently I looked it up, and there is someone decided to call a one-celled bacteria somewhere and just use vowels. I don't know if I pronounced it right. But I'm going to tell you, I'm going to see, can you figure out a 7? Okay. Here's the first puzzle I'm giving you. Can you think of a tree that has 7 letters, kind of tree, and it uses all 5 vowels? That's my first puzzle. My second puzzle, I'll give you another word puzzle. Can you think of a word that starts with he, H-E, ends with he, H-E, but isn't he, or he, or any of those? It's an actual word, starts with he, ends with he, has letters in between. And to make it worse, is in the first sentence of this lesson, I used that word. If you don't remember what I said. That's your second puzzle. First puzzle, all 5 vowels, it's kind of tree. If you can't figure that one out, you can see if you can figure out the puzzle. English word starts with he, ends with he. Questions for practice. Are 3, 5, and 9.